Okay, so we are recording now. So this is Blackboard under the course syllabus, or the course information. To check your grades, you'll click on My Grades. Right now you can see there are no assignments out there. We haven't done any quizzes or anything like that, so there won't be anything there. So let's look at the syllabus quick and get that out of the way. I don't know how big your screen is on that end. Is that big enough you guys can read it okay? Okay, perfect. My name is Todd Hoff. You can call me Mr. Hoff or Todd. It doesn't matter to me. Best way to get a hold of me for you guys is going to be email, todd.hoff@witc.edu, or through your teacher there, they can get a hold of me for you. If you need to call, that is my extension. You can call any of WITC's numbers, 800 number or any campus, and dial that extension. It'll take you to my voicemail. You guys are here, so you don't need to know where and when the class meets. Course description. This is just a math course that is designed for the trades, construction, telecommunications, and machine tool take this course. But each section is kind of woven a little bit into specifically for a program. So we kind of go back and forth between doing some general math, generic math, and then specific applications for what you guys are going to need within a program. If you look at our concepts here, you'd realize we do start out fairly basic. What we're going to talk about today is really basic numbers, but I've found through the years that myself even, I understood how to do the calculations, but I never really understood why. So we'll take a little bit of time to look at some of the number theory behind why we do things the way we do, so that when we get into the more complex stuff, it makes a little bit more sense for us. Textbook is the next big thing. I'll switch this over here. Hopefully they got these all out to you. My focus is a little off there. There we go. So you should have two textbooks that came in a package of two. You have a big one, which is the Technical Mathematics book, and then along with it should have been a small one, Practical Problems in Mathematics for Carpenters. A lot of our homework is going to be out of the small book, but occasionally there are some details, some generic math problems out of the larger book that'll help us fill in some of the things that the small book doesn't quite go into enough detail to do. And then throughout the semester, there will occasionally be some packets that I have for things like working in the framing square and stuff like that that'll get sent out to you. If you don't have a calculator, a scientific calculator is very highly recommended. If you have a graphing calculator, that's fine. One of the things the graphing calculators don't do well is usually fractions. For me, the one that's adequate, usually works the best for this class, is the simple TI-30. That has the fraction capabilities and does everything we need it to do and a whole lot more. Even into the trig and stuff that would be a second semester topic. So you guys are spreading out the first semester over the whole year, so we won't quite get to the trig in this class. I know a lot of students like to use their cell phones for calculators. I don't have a problem with that, but I will just say most of the cell phone apps I've found don't do fractions really well. I've seen one or two that do, but most of them you have to pay for. If that's your preference, that's fine with me, but I'll leave it up to the teacher in the room with you there just to make sure you're not texting someone or whatever during a test or a quiz. Grading. This is my standard grading statement. We got to modify it just a little bit because of the distance. 80% of your grade is determined by unit tests and unannounced quizzes. Now we're fractionalizing this course. We're splitting it up, so we're spreading it out over 2 semesters. So during this semester in the fall here, we're only going to do the first 2 units of the course. So there'll be 2 unit tests. One is going to be arithmetic and the other one's going to be algebra. Obviously with the applications in there. So there will be 200-point tests. Then quizzes will occur about every anywhere from 3 to 4 hours, 2 to 4 hours of class. So generally there will be a quiz most weeks. Sometimes we'll get by without. Occasionally we may get hit with 2 quizzes in a week. The reason I do so many quizzes with the distance like this over the television network, it's really tough I'm not going to collect your homework and grade it. That would require a lot of faxing or scanning and emailing back and forth. So we won't be collecting homework. So the quizzes are kind of my way of making sure everybody's staying on top of the material and testing to see if I have to go back and redo something if everybody's struggling with something. So that's 80% of your grade. The other 20% is homework and class participation. Now I just said your homework isn't collected and graded, so that turns into participation grade. Make sure you're in class, answering questions. If I give you problems to do in your notes, make sure you're working on those. And that's something I'll be working a little bit with your teacher on site with you to have him help me, give me a little input if somebody is, daydreaming in class or whatever, or missing a lot of class and stuff like that. So then we have our standard grade scale. Probably saw this in your other classes. 93 and up is an A, and 85 and up is a B, and so on. I'll let you guys read those on your own. Then the rest is just our standard procedures, our student handbook. Everything applies to this course. If you need to withdraw, we'll handle that. You guys are in the high school, so that'll be handled differently, so I don't need to go over that. The big policies that I need to go over, academic integrity, don't cheat. This is a very good class as far as learning the skills for your trades. If you're cheating, you're only hurting yourself. You're not going to hurt me there. If you have any needs, whether you have a documented disability or maybe just struggle with math, or maybe with the network, you feel funny taking a test on the network and you need to go to you feel more comfortable if you went to a private room or whatever, let me know and we'll see what we can figure out for you. Then just a statement that we are being videoed. These are posted. They're not on a secure server. They're posted on YouTube. So they are out there that the general public can't access them. So don't say or do anything in class that might come back to haunt you later. And then that's our 3 units for the course. We are going to be covering the first 2 units, which is our operations with real numbers, measurements, and some basic areas and volumes. We'll split that up a little bit, do a little bit of algebra in that second part, and put some of the areas and volumes into the spring semester. Okay, so that is the rundown of the course. Anybody have any questions on grading policies or anything like that? Okay. Just to give you guys a little bit of an idea of my background, I'm not just a generic math teacher. My background, before I took my job here at WITC, I was a structural engineer, mostly on construction sites. Spent some time in the roof and floor truss industry. While I was in college and before I ended up full-time engineering, I did run a construction company. Ran that part-time on weekends and summers up until about 2 years ago. Finally decided I didn't want to work that hard anymore. So I do have a lot of construction experience, so I will try to tie everything that we can into construction applications for you. Okay, with that, as you saw in our list of topics, we start out with some pretty basic math. And as I said, I want to take the time to show you a little bit about why we do things the way we do. So I'm going to start out today with some really simple topics, but very misunderstood topics. Make sure I've got the full screen. Okay. So the first topic I want to touch on is the idea of a number. Now you might be sitting there thinking, wow, I know what a number is. I've known that since I was like 3. But it's often misunderstood. If I put a 4 up here, a show of hands, how many of you would tell me that that's a number? Most people would, right? A little shy now? Yeah, that's fine. Some of you might be thinking, well, they know there's something coming. 4 is a numeral. It is an amount. It's telling us how much. To truly be a number, it has to tell us not only how much, but of what. So we might have 4 cows. Now it's a complete number. We have the 4 telling us how many. I'm going to refer to that as the count. And then we have cows, which is telling us what it is we have 4 of. I'm going to refer to that as the name. Now you might be looking at this thinking, oh boy, another one of those teachers, one of those math teachers is going to require us to label everything. That's not my reason for pointing this out. I'm not going to be a stickler. If you forget to put the inches on it, I'll forgive it the first couple times. And it's not my point to terrorize you with labels and units. What it is if we keep those 2 parts of a number in mind, it defines the process we use in our basic operations with all the different forms of numbers. We've been taught that there's a different process for combining different types of numbers. And it's really the exact same process. It just looks a little different. So let's look at our basic math operations and how numbers behave with those 2 parts. So we're going to look at addition. Now, subtraction, we've all been taught subtraction, but it's really just part of addition. So anything that applies to addition will also apply to subtraction. They're really the same operation, just addition is going forward and subtraction is going in reverse. In fact, the most technical definition of subtraction is as a form of addition. And then we'll look at multiplication, and of course, along with multiplication is division. And the same thing goes there. Division is really just part of multiplication. Multiplication is going forward, division is going in reverse. So let's take a look at adding 2 numbers. Let's take maybe, well, since we're in construction here, we'll do 4 inches plus 7 inches. What do we get? Go ahead and feel free to speak up. 11 inches, right? Perfect. Let's take a look at what happened with our 2 parts of the number. We've got our counts here, 4 and 7. They ended up making 11. We combined them. We're adding here, so we combined them with addition. So when we add numbers, we combine the counts. Let's look at the names. We had inches, and it became inches. It just stayed inches. So when we add numbers, we keep the same name. Well, again, not terribly groundbreaking yet, but let's look at what happens when we multiply. If I take 4 inches times 7 inches, what do we get? Well, 4 times 7 is, no need to be shy. Remember, class participation counts. 28. We'll warm up hopefully as the semester goes on. But 28 what? Not inches, but you think about it, if I'm multiplying 4 inches by 7 inches, generally I'm trying to find the area of a rectangle. That's going to be inches squared. So a slight difference there with our multiplication. So if we look at our multiplication here, looking at our counts, we had 4 and 7. We still combine them. This time they make 28. We're multiplying this time, so we combine them with multiplication. So when we multiply, we still combine the counts. The difference is in the name. This time we had inches, and it became inches squared, or square inches. When we multiply, we also combine the names. Now that seems like a very small difference, but it's really huge. That difference explains why we do all the different processes with our other forms of numbers. In fact, it even explains what we can and cannot use in each operation. For example, let's say I go back to my example of the cows. Let's say we have 3 cows plus 5 boys. Does that give me 8 cowboys? That doesn't work, does it? Or if I switch it around. I had 5 boys and 3 cows. Does that give me 8 boy cows? Okay, obviously not. Anybody with a farm background in the room? Show of hands. A few of you. So you can tell me that that is a whole bunch of bull, right? Long way to go for a joke. I'm a math teacher. I'm required to have a really stupid sense of humor. But there's a point behind that joke. When we add numbers, we're going to keep the same name, which implies that we had to start out with the same name. Inches and inches just stays inches. Here we had cows and boys. We had different names, so we don't know what name to keep. Because of the fact that we're going to keep the same name, when we add numbers, we must start with the same name. Let me show you here in a little bit more explicit form. So if I have something like 5 feet plus 2 pounds, I cannot add those because they have different names. So if I try to add 5 feet plus 2 pounds, I get 5 feet and 2 pounds. But over here on the other side, if I wanted to do 5 feet times 2 pounds, when I multiply, I combine the counts. 5 times 2 makes 10. And then I also combine the names. Feet times pounds is just foot-pounds. If you're in mechanics, that's a unit of torque. In construction, for you guys, that's going to be a unit of moment or bending in beams and posts and stuff like that. So when I multiply, I don't need the same name. And you might be looking at it thinking, okay, big deal. What does that help with everything else? Well, when we go to look at our other forms of numbers, it explains all those special rules that we were taught. Let's look at everybody's favorite type of number, a fraction. I saw some of the looks. I realized that if I asked people on their way into class what they hate most about math or what they struggle most about math, 4 out of 5 would probably say fractions. Just a little review. What's the top number called? Starts with an N. Numerator, there we go. And the bottom number? I heard somebody whisper it there, denominator. You saw me pause there. I should take a quick side note. I am a terrible speller. There's a reason why I teach math and not communications. Saw me pause in the middle of the word there. Sometimes I get halfway through and I forget how to spell it. I also realize that my handwriting is sometimes a little sloppy. If anything ever appears up here that you can't read, I promise you it was intended to be in English, but I either just horribly misspelled it or my handwriting's off. Don't be afraid to jump in and ask me what something says. I promise I won't be offended. Okay, so we have the numerator and the denominator in our fractions. Let's look at what those mean. What does it mean to numerate? Well, every 10 years, our government sends out people to do the census to numerate the population. What are they doing? They're counting. So a numerator is a count. Denominator, what does it mean to denominate? Well, we have different denominations of money, different denominations of organizations. To denominate means to classify or to give a name. So a lot of people look at fractions and they see 2 numbers, but it's not true. We have one number with 2 parts. Just like having 4 cows or 3 inches or whatever, here we have 3 of something. What we have is not cows or inches, it's now sevenths. So the 7 is a name. And in a little bit, actually probably next class, we'll look at what does it mean to be a 7th. So anyway, for now, let's take a look at what our rules of numbers, our 2 parts of numbers, do in our operations. So let's take 3/7 plus 2/7. If you think way back to like 3rd grade or so, when you first started doing operations with fractions, your 3rd grade teacher said to add fractions, you must have common denominator, right? That's not a special rule for fractions. With any number, when we go to add or subtract, we must have the same name. So for our fractions here, 3/7 plus 2/7, we were told that you're going to combine you're going to add the numerators. 3 plus 2 is 5, and keep that common denominator of 7. Again, that's not a special rule for fractions. Anytime we add numbers, we combine the counts. In a fraction, that's just adding the numerators, and then we keep the same name. In the fraction, that's just keeping that common denominator. So what if I have something like 1/3 plus 2/5? Can I add those the way they're written? No, because right now they have different names. This is thirds and this is fifths. Again, in the next class, when we go to work with fractions in more detail, we'll look at different ways of renaming those so that we can combine those with addition or subtraction. Let's look at multiplication. 3/7 times 2/7. When we multiply, if you remember way back, how were we taught to multiply fractions? We're taught just multiply straight across, right? Numerator times numerator, denominator times denominator. Again, that's nothing new for fractions. Anytime we multiply, we combine counts, and we also combine the names. So we're going to do 3 times 2 is 6, and then 7 times 7 is 49. When we come down, if we try 1/3 and 2/5, do we have to have a common denominator to multiply? No. When we multiply, we do not need the same name. So when we multiply fractions, we do not need a common denominator. Again, not a special rule for fractions. That's how we work with all numbers. So then we just multiply the counts, or multiply the numerators. 1 times 2 is 2. And then multiply the names, or the denominators. 3 times 5 is 15. Let's look at decimals quick. Something like 0.21. Now the formal way of pronouncing that would be 21 what? Someone say hundredths. And when we see it written that way, it's pretty obvious where's the count, 21, and the name is the hundredths. So if I want to add a couple of decimals, let's say I'm going to take 0.21 plus 0.4. Is that going to work? No, it's not. Why not? Well, we were taught that when you add decimals, you need to line up the decimal points. So we have to write this 0.21 and put the decimal point straight below it, so the 4 has to go below the 2. Well, the question is, why do we have to line up the decimal points? Well, we already said this is 21 hundredths. This is 4 tenths. They have different names. But all we have to do is put a 0 here, and now that is 40 hundredths. And if that 0 is in there, now the decimal points automatically line up. So lining up our decimal points is nothing more than making sure they have the same name. So now we go ahead and add 21 and 40 is 61. What do we do with the decimal point? We just bring it straight down. Again, when we add numbers, we keep the same name. 21 hundredths plus 40 hundredths has to be 61 hundredths. Moving the decimal point down is nothing more than keeping the same name. When we multiply, do we have to line up our decimal points? No, we don't. So we're just going to go ahead, when we multiply, we don't need the same name. So we'll go ahead, 21 times 4 is 84. Where's our decimal point have to go? So we go 1, 2, we have to add a 0, and 3. We were always taught, you count in the problem, 1, 2, 3 decimal places total in the problem. You have to have 1, 2, 3 decimal places in the answer. Well, the question that's always looming out there is why? Well, this is 21 hundredths still. This is 4 tenths. When you multiply fractions, or when you multiply any number, you multiply the counts. 21 times 4 is 84. But you also multiply the names. Hundredths times tenths is thousandths. So when we're counting up those decimal places in the problem and putting that many decimal places in our answer, all we are really doing there is multiplying the names. Let's take a look at algebraic numbers. 4x. Some people get a little nervous when they see that. Putting variables in with our numbers or letters in with our numbers is a little uncomfortable for some. But this is still just a number with two parts. We have the count, which is our 4. Just like having 4 inches or 4 sevenths, we have 4 of something here. And our name, which is the x. Now the difference is we know what an inch is and we know what a seventh is. We don't necessarily know what x is, but it really doesn't matter. When we go to work with it, it works exactly the same. So if I want to add 4x plus 11x, what do I get? Well, when I add numbers, I combine counts. 4 and 11 make 15, and I keep the same name. So x and x stays x. What do I get when I try to add 5x and 2y? I get 5x and plus 2y. I cannot combine them any further with addition and subtraction because they have different names. Just like my 5 feet and 2 pounds, they had different names, so I cannot combine them with addition or subtraction. You've always been taught you have to have like terms to add algebraic numbers, to add algebraic terms. Well, that's the reason. In any form of number, you have to have the same name to add or subtract. When we multiply 4x times 11x, we multiply the counts. 4 times 11 is 44. Then we also multiply the names. Just like inches times inches become inches squared, x times x becomes x squared. For multiplication, if I tried to multiply 5x times 2y, we don't have the same name, but it doesn't matter. When we multiply or divide, we do not need the same name. We multiply the counts. 5 times 2 is 10. Then we multiply the names. Just like feet times pounds became foot pounds, x times y becomes xy. I often get asked, could we say 10yx? There's nothing wrong with that. It's just a little bit of a grammar and math, kind of a math grammar thing, is we try to put variables in alphabetical order. Okay, so there's kind of a whirlwind tour of our first basic topics of the course and that underlying concept of count in the name and a number and how it falls into place. You might be looking at that thinking, big deal. Some of you might think it's a little bit interesting, but how does it fit in with what we do with larger numbers? Well, it defines our processes that we use for our hand calculations with larger numbers. Now, I'm going to show you these hand calculations today just as a review for you. I realize that you have calculators and you're probably going to use them. And on every quiz or test we do in here, you will be allowed to use your calculator. But I use a word of caution. I've shown up on several job sites where I got sand or dirt in one of the keys of my calculator and it won't work. Or I set my calculator in the dashboard of my truck and it overheated and now it's not going to work right for me. Okay, so anyway, I've had a lot of times where I've had to do some relatively complex calculations by hand because they had to be done there. My calculator wasn't functioning and I didn't have time to go get another one. Now I realize now, in the last 10, 12 years, cell phones have calculators, and so you always, as long as your cell phone's working, you have a calculator with you, but cell phone batteries die and whatnot, so it's good to have some basic calculating skills, even if you don't do the exact calculation, just to be able to estimate. And we'll talk about that a little bit too as we go. So the concept that ties all of this that we just talked about into our operations with larger numbers is the concept of place value. Now, I'm not going to dwell on this because I know you guys know place values. But just a quick review, we have the ones, the tens, and the hundreds. And those are our only three place values. They're repeated over and over again. Ones, tens, and hundreds. Ones, tens, and hundreds. And so on. This here is our base group. This is the thousands group. Then our millions group. Then our billions group, and trillions group, quadrillions group, and so on. If you guys ever get past the 100 millions, they'll be able to hire somebody to do your math for you, so you don't have to worry about it. So when we name a place value, we name its place and its group. So this is just the tens place. Well, this is the 10,000s, and this is the 10 millions, and so on. I'm not going to bore you with pronouncing numbers or anything like that, but I do want to show you something like this. 586. We're used to seeing that as the expression of a number, but really it's not the complete number. That is just an abbreviation. The full form of that number looks like this. 5 hundreds and 8 tens and 6 ones. And when we see it written out like that, we can see that each digit here is a count and a name. This is not just a 5, it's 5 hundreds. This isn't just an 8, it's 8 tens and 6 ones. Each digit has a count and a name. The name is just the place value. Now another thing those place values are good for is when we go to round. Again, I'm not going to dwell on this very long, but let's look at 3,854. If I give you that and ask you to round to the nearest 1,000 or 1,000. Of course, if I round that to the nearest 1,000, what's it going to be? $4,000, right? We all know how to do it. Where does that come from? Well, the technical definition. And in math, we have a lot of processes that relate to the number line. What that's saying is we have a number line that's numbered in thousands. And it's asking us if we were to put this on the number line, 3,854, which is right here. Physically, which thousand would it be closest to? Well, it is closest to the 4,000. Now, we're not going to draw out number lines every time we round a number, so we have shortcuts, of course. If we want to round to the nearest 1,000, the first thing we have to do is find the thousands or the 1,000s digit. That's right here. That's the 3. What that 3 is telling us is that we are between 3,000 and 4,000. That 1,000 and the next one up. So then, of course, we look at the next digit. The 8, it tells us, we know that if that next digit is 1, 2, 3, or 4, we know we're closest to the lower one. If it's 6, 7, 8 or 9, we know we're closest to the next one up, the higher one. Of course, if it's a 5, it could be a little bit of a difficulty. If that next digit is a 5, what have we always been taught to do? Round it up, right? 5s get rounded up. And there's a good reason for that. For example, let's say that I give you the number 3,527. That's still a 3 in the thousands place. So we're still between 3,000 and 4,000. Here's my that next digit is a 5, which is right in the middle. But you'll see it's 527. So it's actually slightly past the middle. So those digits that come after the 5 push us past the halfway point. That's why we've always been taught, you see a 5, you just round it up. You just do. That's what we've accepted. Well, it's the stuff that comes after the 5 that pushes it past, that we round up. The only time it's ever really an issue if it's just 3,500. Now it is exactly in the middle, and we still, this is where we have just accepted that we're going to round that up to 4,000. Okay, I'm not going to talk anymore about rounding. Let's take a look at our basic operation of addition. So let's take something like 427 plus 341. I'm going to write these out in their full form, sometimes called expanded form. So this is 4 hundreds and 2 tens and 7 ones. 341 is 3 hundreds and 4 tens and 1 1. Each digit, as we see, has a count and a name. We learned about half an hour ago that when we add numbers, we can only combine things that have the same name. That comes right down to the digits. So these 4 hundreds can only be combined with other hundreds. These 2 tens can only be combined with other tens, and so on. That's why it's been stressed to us since first grade or even kindergarten. When you add or subtract numbers, you got to line up the columns. Well, that's because we can only combine things with the same place value when we add or subtract. So once they're lined up, we can just go ahead and add down the columns. 4 plus 3 is 7. 2 plus 4 is 6. 7 plus 1 is 8. Now, some of you might be looking at that thinking, he did something weird there. Can anybody tell me what it is? There it is. I went backwards. I started on the left, and I went to the right. We've always been taught that you should start on the right and work your way back to the left. Why? Why do we want to go from right to left? In case we have to. You were saying it? Not necessarily round up, but there we go. In case we have to carry. Perfect. If it's bigger than 10, we have to carry it to the next digit. So we might have something like 568 plus 259. We were taught to start on the right and work our way back to the left. Start at the end and work our way back to the beginning. Because we run into 8 plus 9 is 17. We can't have 2 digits in the same place, so we're going to keep the 7 and we're going to carry the 1 to the next digit, next place value. 1 and 6 is 7, plus 5 is 12. So once again, we keep the 2 and we carry the 1. 1 and 5 is 6, plus 2 is 8. And that's how we were all taught how to do addition. Now, that process of carrying is actually a relatively new process. It's only a couple hundred years old. Now, no, I don't remember when we didn't use it. But you don't need to write this down. I just want to show you there are other ways of adding. Before carrying was popular, one of the possible ways you would add these numbers would look like this. 5 plus 2 is 7. 6 plus 5 is 11, so 1, drop the 1. 8 and 9 is 17, so 7, drop the 1. 7 and 1 is 8. 1 and 1 is 2, and 7. We get the same answer. This is a little bit shorter, but we get there the same way, and it would work every time. Like I said, I'm not trying to change how you add numbers, but I show you this just to make a point. We've always been taught that there's only one right way to do things in math. That's not totally true. There is only one correct answer, but there are several right ways, possible ways of getting to that answer. So some of you may have different ways of doing things than what I show you. As long as they work every time and will always get you to the correct answer, that's great. I think that one of the mistakes in teaching math is trying to force you to do it my way. If there's a way that you like and you remember, you're more likely to remember it and be able to use it when you get out on your own. If you have a method of doing things that you're not sure if it's going to work, let me know and I'll look it over and I'll let you know if it's going to work every time or not. Okay, now on the realistic side here, I am a realist. I know that you guys have calculators and you're going to use them since you're allowed to. But before you punch this in a calculator, I would like you to look at it and get a little bit of an idea of what to expect so that something like this doesn't happen. If I punch in 568 plus 259, and I get 597. Does that sound reasonable? You can see the 259, the 5 didn't register when I went to touch the key. If I'm not paying attention, I can write that answer down and go on with life because the calculator said it and not catch it. So before I punch it in the calculator, I would hope you'd do something like this. Look at the 568 and say, that's close to 300. 215, or 300. That's close to 600, I should say. My little hamster's starting to slow down for the day, too. 259, that's close to 300. I'm expecting an answer somewhere around 900. 827's in the ballpark. I know it's not that's not a ridiculous answer. Now, this is just how I estimate. You might have different ways of estimating. Just like I said before, find a way that works for you, that's easy, and that you like doing so that you will do it. I'm not going to try to force you to do it my way because then if you don't like it, you might do it a couple of times, then you'll just forget about it after that. I mean, another problem that I have with these is sometimes I've got these fat fingers, and if I'm using a cell phone calculator, this happens to me a lot. 568 plus 259. You get 3,157. What happened there? I had an extra key, didn't I? I put it, when I went to hit the 9, I hit the 8 as well. But again, if I'm not paying attention, I write down 3,157 and I go on with life and it comes back to haunt me later because that's wrong. And in the construction industry, a mistake like that could cause some major issues. I mean, the least of your problems would be that you'd have to recut something and waste some materials. Okay, let's look at subtraction quick. 587 minus 324. Now, I'm not going to write this out in the long form. I think you guys get the picture that when we add or subtract, we can only combine things that have the same place value, same name. So that's why we have to line up our columns. So once they're lined up, just like before, we're going to go ahead and subtract. 5 minus 3 is 2. 8 minus 2 is 6. 7 minus 4 is 3. We get 263. Some of you may have caught it. What did I just do there again? I went backwards, didn't I? I went from the left to right. Normally we start on the right and go back to the left in case we have to. It's not borrowing with subtraction, or not carrying, it's borrowing, sorry. So in case you have something like 728 minus 289. We start on the right and work our way back to the left because we run into this. 8 minus 9 can't be done. So borrow from the 2, that's a 1. That's an 18. 18 minus 9 is 9. 1 minus 8 can't be done. We'll borrow again. So that's 6 and 11. 11 minus 8 is 3. 6 minus 2 is 4. So we get 439. Now again, just like I did with addition, there are other ways of subtracting. Before borrowing became popular, one way to do it might have looked like this. Again, I'm never going to ask you to repeat this, but just showing you for an example. 7 minus 2 is 5. 2 minus 8 can't be done, so I'm going to take from the 5. That's a 4. This is a 12. 12 minus 8 is 4. 8 minus 9 can't be done, so I take from the 4. That's a 3. This is an 18. 18 minus 9 is 9. I get the same answer. This is just a little bit different form of borrowing. I'm borrowing from the previous result rather than the top number of the column. I get to the same result. As I said, I don't expect you to change how you subtract. Just be aware that there are different possible methods, different possible algorithms. I could show you 4 or 5 different methods of adding and subtracting that work for whole numbers every time. I'm not going to do it because I don't want to confuse you, but keep that in mind that just because the way you do it is different doesn't mean it's necessarily wrong. Again, I acknowledge you're going to use the calculator when possible, so you're probably going to punt, especially 3-digit addition and subtraction. But again, I would hope that you would look at this and say, okay, I got about 700 minus about 300. I'm expecting something close to 400. So 439 is in the ballpark. It doesn't guarantee that you don't do something wrong, but it keeps you from making the ridiculous mistakes. Let's look at multiplication. Let's do 32 times 21. This one I am going to write out in full form. So it's 3 tens and 2 ones. 21 becomes 2 tens and 1 1. When I multiply, do I need to have the same name? Say no. No, there you go. So what that means is not only can these 3 tens here combine with these 2 tens, but it can also combine with the 1s or any other digit in the second number. In fact, when we multiply, because you don't have to have the same name, every digit in one number can combine with every digit in the other number. And that's all that long multiplication is an organized method of making sure every digit in the first number gets combined with every digit in the second number. Now, depending on what region you're in and what country, if you're in a foreign country, they often start in different spots for long multiplication. In this area, we're generally taught you start with the bottom number and its last digit. So we're going to start with the 1 1. And then you start multiplying every digit in the top number. You start at the end of the number and work your way backwards. So we have 1 1 times 2 1s. Just like we mentioned earlier, you combine the counts and then also combine the names. So 1 times 2 is 2. It's a positive 2. 1s times 1s is 1s. Then we multiply the 1 1 by the 3 tens. Again, we combine the counts. 1 times 3 is 3. And we combine the names. 1s times 10s is just 10s. Now we've combined that digit with every digit in the top number. So we can move over to the next digit in the bottom number. Before we do that, what have we been taught to do down here? Put in a 0, right? Or leave a space. So now when we come back up there, 2 tens times 2 1s. Well, again, combining the counts, 2 times 2 is 4. It's positive 4. 10s times 1s is 10s. Putting in that 0 is nothing more than making sure we line up our place values with like place values. So now we have the 2 tens times 3 tens. 2 times 3 is 6. 10s times 10s is hundreds. And now we combine 2 1s. There's nothing to combine with it. 3 tens and 4 tens is 7. And 600. So 672. Now again, I realize that you're not going to do a lot of long multiplication. You're going to put it in your calculator. So I'm still hoping that you look at this and say, okay, 30, that's about 20. When we multiply, 2 times 3 is 6. Now when we added or subtracted, we just kept the same number of zeros. When we multiply, We have to combine the zeros. Tens times tens is hundreds. So we're expecting an answer close to 600. Now you might be wondering, why am I showing you all this? It's tedious. You learned it like 8 years ago. Why am I going through it? Well, when we look at algebraic numbers and algebra variables, the operation for multiplying algebraic numbers looks exactly like this. Adding or subtracting algebraic numbers looks exactly like that. If we were good at working with whole numbers in their expanded form or long form, our operations with algebraic numbers looks exactly the same. Okay, before we get to division, I want to make a little bit of a note about the mechanics of multiplication. We looked at multiplying the big numbers, but we didn't really look at what does it mean to combine the values. So let's look at 5 times 3. Now we all know that's 15. But if we go back to like first grade or so, when we were first learning to multiply, and before we'd memorized our multiplication tables or our multiplication facts, before we knew that that was 15, how did we figure it out? Well, we did 3 5s added together. It's 5 3 times, right? 5 times 5 plus 5 plus 5 is 15. Multiplication is defined to be repeated addition. So now, when we divide 24 divided by 8, if multiplication is repeated addition, division can be thought of as repeated subtraction. 24 divided by 8 is asking how many times can we subtract 8 from 24. So 24 minus 8 is 16. That's once. Minus another 8 is 8. That's twice. Subtract it again to get 0. That's 3 times. 24 divided by 8 is 3 because we can subtract 8 from 24 3 times. That actually even describes our division and remainder system. For example, let's say I have 33 divided by 7. I start out with 33, I subtract 7, I get 26. Subtract 7 again is 19. Subtract 7 again is 12. Subtract 7 again is 5. Can't subtract 7 from 5 unless I'm going to go negative. So I subtracted 7 1, 2, 3, 4 times with 5 left over. Therefore, 33 divided by 7 is 4 with a remainder of 5. There are some applications in math, a lot of applications actually in construction math, where that remainder is more useful than the decimal. And we'll look at those applications as we go through the semester. So what does all this have to do with long division? Let's take a look. Well, let's take 68,942 divided by 21. Now, we just said that division is repeated subtraction. Well, I am not about to start subtracting 21 from 68,000. We don't have that kind of time. But if I think about, let's say I had 27 divided by 2. Instead of just subtracting 2, I might subtract 20 to get 7. What did I do with that 20? Well, where did it come from? What I was doing is I was going to subtract a bundle of 2's. The 20 is 10 2's, and I subtracted them all at once. Long division is nothing more than a process, an organized process for subtracting a number in large bunches, in large groups. Now, you don't have to write this down. I'm not going to change the way you do long division. But let's take a look. Figure out, first of all, how big of a group do we start with? Well, we look at the number we're dividing, and we look at its first place value. That 6 is in the 10,000s place. So we take 10,000 times the number we're dividing by. 10,000 times 21. That's 210,000. Can I subtract 210,000 from 68,000? No, it's too big. So I move to my next place value, which is the thousands place. 1,000 times 21 is 21,000. That I can subtract. Now technically I should do this. 21,000, subtract another 21,000, and subtract it till I can't anymore. I'm going to take a little bit of a shortcut. And I look at that and I see I can subtract 21,000 3 times. So 21,000 times 3 is 63,000. That leaves me when I subtract, I've got 2, 4, 9, and 5. So what I just did there was I subtracted a group, a bundle of 1,021s. And I did it 3 times. That's 1,000 times 3 for 3,000 times. I just subtracted 21 3,000 times. So now I move down to the next place value, which is hundreds. 100 times 21 is 2,100. Can I subtract that from what's left? Sure can. In fact, I can do it twice. 2,100 times 2 is 4,200. I subtract, I get 2, 4, 7, and 1. So again, what I just did was I subtracted 121s, and I subtracted that bundle twice. 100 times 2 is 200. Next place value is tens. 10 times 21 is 210. I can subtract that here. Looks like 8 times. 210 times 8 is 1,680. So that's 2. Borrow here, that's 6. 14. That's 6. 62. So I just subtracted a group of 10 21s, and I did it 8 times. So 10 times 8 is 80. I just subtracted 80 more 21s. And then, of course, all I'm left with is just the 21 itself, or 1 times 21, if you will. I can subtract that from here twice, which would be 42, with 20 left over. So I subtracted it twice more. So when I divide 68,942 by 21, I get 3,282 with a remainder of 20. Now you might be looking at that thinking, that looks absolutely nothing like the long division we were taught. And at the surface it doesn't look anything like it, but it's actually exactly what we were taught to do. Just abbreviated. I'll show you here quick. 68,942 divided by 21. Here's what we were taught. You look at the first digit here, 6. Can 21 go into 6? No, so you leave it blank up here. That's exactly what we did here. We tried 10,000s. It was too big, so we didn't use it. We moved to the next place value, so we left it blank there. 21 goes into 68 3 times. 3 times 21 is 63. We subtract to get 5. Now, if you look over here, again, it looks very different, but if you can compare this to this, all we did was left off the zeros here. Bring down that next digit, the 9. 21 goes into 59 twice. 2 times 21 is 42. We subtract, we have 17. Again, all we did here, we left off the zeros. So it's the same process, we just extremely abbreviated it. Now, once again, I understand that you have the calculators, you're going to use them. So you're going to look at this 6,894, or sorry, 892, 890. Let me try that again. 68,942 divided by 21. And you're going to punch it in the calculator. But again, I hope that you would look at it and say, okay, this is close to 70,000. 21 is about 20. When I estimate with my division, rather than combining zeros, I'm going to cancel them out. So I have 1 0 here. I'm going to take 1 0 off of here. So now I'm just dealing with 7,000 divided by 2. 7 doesn't divide by 2 real neatly. So there's several ways I can go about it. I'll just show you a couple of the ways I use. You, again, come up with your own way of estimating that works for you. Sometimes I'll take 70 divided by 2 is 35, and then I have 2 zeros left. So I'm expecting that to be close to 3,500. Another way, looking at my 7,000 divided by 2, I've already canceled off the 1 0. I might say, well, 7 divided by 2 is between 3 and 4. So my answer is between 3,000 and 4,000. So I know that I'm hoping for something between 3 and 4,000. Okay, normally for the class, for the classes we teach here, we try to do about 2/3 of the class is lecture and about 1/3 is work time. For you guys, we're going to not do quite as much work time because I realize you guys have other independent work time outside of class. But I think for the day, for the first day, you guys have listened to me long enough. I can see you guys about ready to tip over out there. So we're going to look in your little book. It is set up in units. So what we've looked at so far is units 1, 2, 3, and 4. Now I'll leave it up to, I don't know if they want you writing in the books or not. Again, this is in the little books, the small book, the practical problems. These have all the story problems in it that deal with carpentry applications. What I want you to do in those problems is 2 things. One, I only want you to work on the odds. Reason for that, 2 reasons. One is I don't want you to have like 150 problems to do between now and Friday. Second, the answers to all the odds are in the back of the book. So as you're doing your problems, check them to make sure you're doing them correctly. I don't want you to do like 20 problems and then looking back and realize you've done them all wrong. I don't want you developing bad habits like that. Check 1 or 2 problems, do 1 or 2 problems, check them over, make sure you're doing them correctly. Also, I realize, especially at the beginning of the course, the first few problems in an assignment might be real easy for you. If they are real easy, do feel free to skip ahead a couple of problems and try more difficult ones. I don't necessarily want you to do busy work on stuff you already know how to do. Make sure you're doing enough problems that you are adequately prepared for a quiz, because there will be a quiz coming up fairly soon. I believe the first quiz will be next week, Wednesday. With that, like I said, I'll give you the last whatever time we have left here to work. Mr. Berghammer, do you know do we actually end at 3:30 or do we end a couple minutes before 3:30?
Oh, yeah, well, if you want to end a couple minutes early, it's nice, then I can just give these guys a heads up on what's going on for the last couple minutes to brief them for tomorrow and a couple things.
Okay, generally, like I said, I usually try to give them the last 10 to 15 minutes to work. I have another class that comes in at exactly 3:30, so it's nice if I shut down the network a few minutes so they have time to come in. So generally, 3:20, 3:25, I'll probably shut down the network.
That's fine. Totally up to you. We'll work around your schedule.
Okay, sounds great. So they want a little bit of time to work now. That's fine. Otherwise, you can take over if there's stuff you need to do. Just go ahead and mute the mic, and I'll shut down the system in about 6 or 7 minutes. So if any questions pop up, feel free to turn the mic back on and ask me.
Just one quick question. These little books, do they change year to year, or they've been pretty much the same? I'm just trying to think if it would make sense for us to write in them or if we should not.
They stay pretty much the same. They change about every 2 or 3 years when they get a new edition. But realistically, for you guys, if you're going to do this year after year, keep them, and I'll just keep a copy of the old edition so that as we teach this course year after year, I'll have the old edition and we'll just keep using it so you don't have to buy new ones.
All right, and we'll make sure that they write it on paper then. They'll write their answers on paper.
Sounds perfect.
So you want us to work on units 1, 2, 3, and 4, the odd problems, correct?
That is correct. And like I said, if the first couple are real easy, don't be afraid to skip a couple problems and do more difficult ones.
Okay.
The biggest thing is with the word problems, I want them to get used to reading and picking out information from a word problem, because that is one of the skills that people struggle developing as we go through.
Okay. Thank you.
Thank you. You have a great day.